Welcome to our tutorial on driving digital transformation through flexible and compliant business processes. This is a tutorial at the 39th International Conference on Conceptual Modeling. My name is Stefanie Rinderle-Ma, and together with my colleague Jürgen, I'm happy to dig a little bit deeper now into digital transformation and what business processes can do. And we want to look at this from a particular application domain, which is, let's say, a killer domain for digital transformation and business processes. And this is the manufacturing or production domain. So why would we look at the manufacturing domain? So one reason for this is that, according to our experiences, manufacturing processes have it all. So as you can see here, they have quite some complex process structures and networks. They combine the physical world with systems and human workers. So, for example, such manufacturing processes invoke machines and also are subject to sensor data, but also human work is involved in these processes. And of course, there are all kinds of information systems invoked too, such as MES, for example. So maybe let me start with giving a glimpse in a real-world production setting, which is process-driven. And this setting is executed at the so-called pilot factory. The pilot factory is, let's say, a factory that is a real-world factory and produces all kinds of parts, but can be also used for experimental settings. And due to our collaboration in the context of the Austrian Center for Digital Production, it's also possible that we experiment with our business process-driven solutions here. So what you can see, and I will start the video in a moment, is that on the left-hand side you can see a screenshot of the process that drives the machine and the robot that you can see on the right-hand side. And this is the process engine that was developed by our research group, Workflow Systems and Technology. So the core, the open source process engine is the Cloud Process Execution Engine, CPE. And this was further developed into the, let's say, more manufacturing-oriented solutions in Turio.work. So, but now let's start the video. So what you can see here, on the left-hand side, as I said before, is, let's say, the super process that drives everything. And during runtime, so now it's a concrete process instances executed, several sub-processes are spawned. And we see now in the first step, there's the production. So what we are producing here is a chess tower. So you can see here, this is like the inside of the machine, and the several sub-processes now drive this production. So now you can see how the machine starts to work, and you can see the workpiece there in front. This is going to be the tower in the end. And now the machining is executed. You can see now there's several things are milled here. Now you can see the shape of the tower is carved out, so to say. Well, I'm no engineering expert, so hopefully I'm not using the totally wrong terms here, but anyway, you now can see how the tower is created. And everything, like what happens, this is the interesting part here, maybe also from a process perspective, everything that happens now within this production of this instance is collected by the process engine in parallel to executing the process. And this is very interesting because you can see that the data that is produced here, for example, sensors measuring some important parameters and so on, can be collected, but not only collected now in isolation, but in the context of the entire process. and for the specific process instance. And therefore, a process-oriented solution is also so interesting with respect to the contextualized collection of process and manufacturing data. Now you can see this from a different angle, yeah, and now the tower is cut. Okay, looks already like a chess tower, so there's now some fine-tuning done. And you can see this data collection is on the very, very right side. There was this fetch task that was running all the time through. Okay, now the production is finished, and now you can see other sub-processes have been spawned. And what is now done, that the control of the process kind of shifts to the robot now. The robot is now taking out the part from the machine. It's a little bit slowed down here, such that we can see this individual steps. Typically, maybe it would be faster, but you can see, okay, now this is now in the executing the task grip here. And in parallel, you see it's already there is some Turm, which means tower, Keynes measurement running. This means that there is also some measuring task run in parallel. This is also interesting because it produces data, of course, which is also collected and can be then also connected with the data that was collected beforehand. And this is quite promising because often data is more collected in, let's say, call it like data silos, yeah, which are kind of disconnected. But here we know what belongs together in a process-oriented way and for which instance and for which machine and so on and so forth. Yeah. Okay. And now the robot has taken out the part and new sub-processes are spawned. And we can see that now the part has been measured and now should be, you can see this here, this is this Keynes measurement, which means a scan, more or less, of the part. Yeah, so the robot holds now the piece such that it can be measured. Again, data is collected. It's not broken or something, it just takes some time, the measurement, yeah. Maybe I skip a bit of this. And then in the end, the robot is now supposed to unload the piece in the last step to a tray. So now the door has been closed. You can see door to portal. And now the final step of unloading the tower to the tray. So this is kind of seen here. Right, so this was now, let's say, the execution of one process instance for producing one tower, yeah, and this was a completely automated process, as you could see, yeah. So we did not have any manual human interaction here. But this is also possible, of course, and this leads me to my second use case. And this use case is from a real-world enterprise factory. Yeah, this is the EFA GmbH, and they produce safety systems, key solutions, and so on. And also this solution, this Centurio.work process software is running there in real-world setting. Yeah, And for example, it supports or it runs the production of this cylinder air key that you can see here. And now we see a process. So please remember, so in the first use case, we have seen a production in a completed automated manner. But now we see a production of this air key, which involves human work. And here you can see a working station, like for this cylinder air key. And yeah, first of all, you can scan here this particular part, which you then are supposed to produce. Yeah, and on the left-hand side, you can see the process that runs this. So yeah, as I said before, the first step is to scan which part is now to produce. Okay, and yeah, the process solution is depicted on the left-hand side. And what is interesting here now is that from the process, it is also possible to generate supporting information, for example, in the form of instructions, to the workers at the workstations. Yeah, so you can see here this user interface is generated by the process solution. Yeah, and what has to be kept in mind here is that this air key comes in, I think it was around 60 variants. So it's not so trivial to produce these instructions because the instructions depend on the variant that is to be produced. Yeah. And you can see the step also in the process as this task show wizard UI here, and you can see that. So this runs through all these stations here, so all these working stations. And yeah, here this was an example for a solution that also includes human work. So what we can do is, and this is the interesting thing about business process, to integrate all different things together. We have the process itself, we have machining and sensor, we have human work, and we have all the systems that are connected. And we can collect data about all these different elements of the work and bring this together in a contextualized way. Yeah, and therefore we made the experience that process technology is really very promising. And I would say it's a key and driver for digital transformation in manufacturing, but also for other application domains that have similar demands and challenges. So we are thinking about like these environments where we have also, say, a strong physical component. Yeah, this would be also, for example, in healthcare or in logistics. And here there's a huge promise because all these different parts and aspects can be brought together. Yeah, so what we have already seen here, we have 2 real-world process-driven manufacturing cases. And now in the following, I want to pinpoint a bit background technology and state of the art. And then in the actual tutorial, which will take place on Friday, 6th of November in the afternoon, we will then use the time to do a demonstration and a hands-on experience in developing a process-driven manufacturing application. And how this will look like, I will show this scenario in the end of this presentation. Right. So what makes this whole area also very interesting from a scientific point of view is that it touches upon a lot of exciting research areas. Yeah, so this is only, let's say, one picture, so there could be, of course, more areas added. So what I regard as really interesting is, so let's say for all of these areas, the basis is business process management. Okay, so process technology. We talk about this here, but then it touches upon, for example, one thing, Internet of Things, with these interface to sensors, machines, and so on. Then there's a high demand for data analysis and visualization. We have high compliance demands, and of course, these processes are not static, but they have to change over time. So we have also high demands on runtime adaptation and repair. And then it's often the case, even more interesting are the interfaces between these research areas. So for example, if you look at Internet of Things and then data analysis and visualization, we see that, okay, we could do process mining, but we can enhance this process mining techniques with sensor data, for example, that we collect, and do, for example, then combined process and time series analysis. And I will go now through these areas and also talk about these interface topics. So let me start with the Internet of Things area. So the Internet of Things and BPM area, of course, follows also the well-known life cycle, let's say, of processes. Of course, we need to think about how to bring these worlds together when modeling the processes, when enacting and executing them, and then also if we do predictions and adaptations. And there was a recent, or there is a recent survey on these particular challenges that arise at the interface between BPM and IoT. And this follows also this life cycle with the challenges. So, for example, in all phases, what is a real important thing to do is to think about how to integrate sensors and machines into the business process. So it starts off with a model where you have to think about how can I annotate the model, but then also, for example, during runtime, thinking about how to log the process event data, but also the sensor data. And then if we manage to do that, then also we have good chances to use both data sources, so the process data and the sensor data, for the combined analysis. Then also, of course, there's a very important human perspective on all of this. So we have to think about what tasks are manual, what tasks are automatic, how can we give worker assistance, and then how can we, for example, in the phase prediction and adaptation, how can we support users in adapting the process? So let's maybe look at the design modeling phase here. So this is a glimpse again at the solution that we have developed. And in our experience, so for example, it was important to say, okay, well, for example, we have the process here, but we also have to think about the label somehow. Yeah, this is maybe, let's say, a basic consideration, but important. We decided to move all of this labeling next to the task. Then also we can annotate these tasks. Yeah, so for example, we can say, okay, well, is this for example, a batch process, a product process, a machine view, and how we collect the sensor data during runtime. And also what is possible to have like a list of models that you can pre-model and then also configure to your needs. So this is also important for the manufacturing domain. So for the human factor, as we saw in the second use case, it's very important to have this worker assistance. Then we can think this further. So this was a worker assistance that showed, let's say a UI where instructions were given. But we could extend this and say, okay, we have maybe more advanced visualizations or even use augmented reality to guide users through their task. Then there's also work, and I think that's also interesting, also of course for other domains, to think about assigning tasks based on the abilities or competences of the workers. Visualizing safety risks, so this is also very important demand here in the manufacturing domain because there are high safety demands, and also on privacy protection. And there were like very recent works on these topics. And what we have also to think about is now to not only model the process, but also go towards their execution, because we really want to execute the processes that then really, as you have seen in this first use case, run the machine and drive the robot and so on. Yeah. So and this necessitates that we have something what we call execution design here, where we specify, let's say, the parameters in more detail. Yeah. So also we have to really think about a very well-defined life cycle for tasks. Yeah, not only have like something like start and end, but maybe also have some intermediate state for handle problems or something like that. Then again, annotation is important, and here we give already a pointer to the research area of compliance. So say, for example, how could we check compliance during runtime here? And of course, if we go through runtime, then we collect also logs, but also we want to collect the data in real time, and therefore come up with more data streams than logs actually. And then we have to also think about how to visualize such data streams during runtime. All right, so a very short overview about Internet of Things, but you see maybe the main challenge here is to bring together the business processes with the physical world such that they can interact. And this has the prospect of, for example, very promising data collection and also very promising inclusion of human workers into the processes. The next area is data analysis and visualization, which we have already prepared kind of by the previous topic, because we can now collect all different kinds of data. We collect process logs, but also event streams, plus sensor data, machining data. So as always, we have in the data analysis and visualization phase, we have different phases to do. We have the data preparation phase, which is often the most complex and tedious phase in a, let's say, BI project. Then we have analysis models to build, then do the actual analysis of the data, and then also we have to interpret and present the results, for example, to management or to other stakeholders. And this is possibly an iterative process. And what has been now very hot topic during the last years, and also now really be very promising for the manufacturing domain, is process mining. And why is this so important, particularly for digital transformation? So according here to this book of Reinkemeyer, we have the need to have transparency as a prerequisite for digital transformation. And process mining allows this full transparency based on the event logs. And I don't give now an deep introduction to process mining, but we want to go through these steps and then more focus on, okay, how can we use process mining techniques, but also combine it with these other data sources, for example, such as sensor data. Here you can see such an event log or also an event stream during runtime. So we collect this in let's say a format that is based on the standard, on the XES standard, but in let's say more in a format that is more geared towards performance, because these logs or streams can become very big. So the process data, as we can see, is event-based. So let's say for starting a particular task, an event will be logged and produced and logged in this log. And here the life cycle is very important. So let's say the more fine granular, we can distinguish between the different life cycle states. Also the more expressive, let's say, the analysis results can be. So we opt at minimum to have a start and a completion event, but also there could be more fine granular events. So here you, for example, you see there's the life cycle transition from the process engine, and this would be that the activity is receiving now. And then we have sensor machining data, and sensor machining data is time series data. So there has been also recent work on this. And time series data then allows the full power of all these like time series analysis techniques. Good question is, do we collect and store this process data and sensoring data in a separated or combined way? Of course, the challenge is that the sensor data is often, let's say, continuous. So it's continuously collected. And then there's really, let's say there's this challenge to link the event data with the matching or correct sensor data. And we need high performance logging, of course, because this can be very big. So, for example, in this, let's say, productions that we have done at the pilot factory, already in this, I would say not so big settings, we had around 80 parameters that we could collect. As the sensor parameters, and also the processes can become big, and then we have to really think about how to do that. Here you see just a visualization, but it shows a little bit the prospect of this. This would be a visualization of possible visualization of these sensor data in addition to the process mining part. And this would be, these are the coordinates of the part to be produced, and you can see here like how the part is then produced within the machine, together with, of course, like a more time-oriented point of view and so on. And visualization is, of course, first of all important to also get some overview of the data and do some explorative analysis. And for the process part, this would be then doing process discovery, so having the logs and then discover the process model and depict it as a graph. This is then also a valid analysis model here. And the model for sensor machining data would be this time series here. And the model for combined analysis is then interesting. So we could say it's maybe an augmented graph. You have in principle the process graph, but then on top of that, for example, statistical models and so on for the time series data. So including like extra data like sensors in process mining is highly promising. So in the state of the art, there has been work on, for example, decision discovery based on data. This means that at, let's say, alternative branchings in the process where a decision has to be made, based on the data that was collected by the process, we can discover the decision rule behind the decision. For example, temperature below 40 or equally or under 40 or something. And there's also for conformance checking, this is another task of process mining where we check to which degree, for example, the behavior that is described by the process model and the behavior that is captured by the process logs match. Also considers more perspectives than just the control flow. So for example, we can think about also the data perspective here, but also the time and resource perspective. These approaches mostly consider like internal process data. So this is data that is produced and consumed by the process itself, which is fine, of course. However, like this external data is also very interesting. For example, we could also, there's some recent work on using external event data for predicting failures in process execution. And also there's data to say, okay, we take sensor streams into consideration, and then we can think about that we explain and predict concept drifts. Concept drifts are drifts in the process execution. So for example, let's say for a certain time, the instances run like described in the process model, but suddenly we encounter, and of course, if process instances are driven by an engine, this has to really then mean that there has been an adaptation of the process. But if there is no process engine behind, somehow also the process event streams or logs might then also show some deviations. And these are called concept drifts, and they can be detected already, but we want to explain them and even predict them. And in manufacturing, we found that if we see drifts in the sensor streams early, here we can use time series analysis techniques such as dynamic time warping, then detect that there are drifts in the sensor streams. And then we've shown that this also is very promising to explain or even predict that concept drifts will then happen in the process. And more precisely, we can predict process evolutions with these drifts in the sensor streams. And for the conformance checking part, so already we have seen that there is related work on multi-perspective conformance checking. that already takes into consideration data, for example, and also this can be extended, for example, to take into consideration sensor streams. And conformance checking lately is done by calculating so-called alignments. So this means, so you have the model, you have the log, and you calculate so how many let's say adaptations I have to do to bring them together, and for each adaptation there's a cost assigned. So I get an overall cost for how much it takes, how many, let's say, adaptation operations I need for bringing this together. And these costs can be also, for example, augmented with insights that we gain from the external data, for example, from the sensor data. And this is then, promising in resulting in a more accurate assessment of conformance in settings where sensor streams influence the process behavior. So I've seen there's plenty to do, and I'm very excited about that. And I would say for this sensor and process data analysis, also for example, the healthcare domain is really interesting. Yeah? So you have also plenty of sensor data here, and also you have, I think, plenty of adaptations going on. And so, for example, it would be also interesting to look into, if now some parameters of the patient start to the sensors, then we see that there's some drift in the data. Can we predict, for example, that there has to be something done with the process? Also quite interesting, and I think this is also one of the most important connections or things you can do when using business processes is compliance. So I think all of the companies and organizations are subject to compliance demands. So in Europe we have the GDPR, for example, as a quite recent example, but there's ISO standards, there's all kind of different regulations, guidelines, and so on that an organization or enterprise has to adhere to. And this compliance is mostly a tedious and effort-full job for the enterprises, and therefore we want to show how we could use business processes to make this task a little bit easier. So as I said before, every enterprise organization has a lot of things to adhere to. This can be also contracts, for example. And if compliance can be shown, there's also some benefits. Of course, you stay in a legal frame somehow, but you can also, for example, create trust, you can show quality levels, and so on and so forth. And compliance is really challenging. So I'm talking about business process compliance here, which means that we check, we have processes at the model level, but also at the instance level during runtime. And we have a set of constraints, and we have to make sure, we have to check that the processes adhere to these constraints. And we have to do this through the entire business process lifecycle. So we have the design phase of the process. So there we have to show that models are conforming to constraints or regulations. Then we have the runtime, we have running processes. So there we have to monitor whether or not these instances comply to the regulations. And we have change. So business processes might change at the instance level, but also at the model level. And still compliance has to be ensured. So which means we have here these challenges through the whole life cycle. And I think, so there has been quite some extensive work on checking compliance for the design time, but also at runtime somehow, but there are some challenges that still pose a lot of open questions on compliance. And these are heterogeneous data sources. So in the manufacturing domain, I think we have motivated that we have plenty of data sources here. Again, we could have the process data, the sensor data, but in addition, we could have all other different kind of sources. Particularly, if we talk about compliance, we have the regulations as data sources, right? So these are textual descriptions, legal texts, and so on. And these are also then the data sources for this problem. And we have processes that might also span across borders, let's say across different companies and enterprises. So they're distributed, and then you run into a whole new set of requirements or challenges with respect to, okay, in these distributed processes, no one knows the entire network of every information because all of the partners keep their internal processes private. Typically, they only show a certain view on their processes to the outside. So how can we check, ensure, guarantee compliance in these settings? And this times symbol here means that for both challenges, we have questions to solve for all the life cycle phases on the left-hand side. And then we have the requirements on the constraints, on these compliance constraints themselves. If they have been already, let's say, extracted and formalized from the textual documents, let's say, then there's already a huge step has been done, actually, which is not kind of implicit here in this figure. And these requirements have been collected in a survey on so-called compliance monitoring functionalities, therefore also this abbreviation CMF here. And they say, okay, constraints have functionalities during their modeling time, so also the constraints have a life cycle. And constraints have, of course, some basic control flow structure. Yeah, for example, A before B or something like that. But also they can refer to time, data, and resources. Then they have an execution phase, and here we have to, for example, think about activity life cycles. We have discussed this before. And, which is really interesting, also this multiple instances constraints here. So there might be constraints that not only refer to, let's say, instances in a separated way, but span across multiple instances. Yeah, for example, in logistics, bundling and unbundling of cargo. And then we have, of course, the user perspective, which is really interesting too. So how can we inform users about possible problems and violations that we encounter? So, of course, we can show, okay, there has been a compliance violation. Then, okay, we can only react on this. But maybe we can also say, okay, during runtime, for example, we might run into problems at a certain point of time, and then we can proactively deal with that. Also very important to explain root causes of violations or quantify the degree of compliance. Also not say like true, false or so, but say, okay, we have 80% degree of compliance, where this is appropriate. And and then also this now multiplies with these requirements, let's say, and so you can see that there is quite some combination of nice challenges and questions that we can still work on. So let me maybe say a few words about these challenges. So here we see there are some collection of data sources that might be interesting. This is again, let's say, from the manufacturing domain, but this holds true also for most of the other domains. So of course we have the logs, the process logs, the event logs, the streams maybe during runtime. Then we have machine and sensor data, but also we have these regulations. Yeah, so let's say the ISO standard, the GDPR, and so on. And in addition, what we have looked into lately is image data, for example, engineering drawings, yeah, where you see how the part was drawn, and also this holds, of course, compliance demands, for example, dimensions that a part has to fulfill, and so there's probably another source here, and this is, of course, also no complete picture, so you see this is becoming then really interesting. And then we have this, this huge demand of how to come up with the constraints from the textual legal descriptions. And this is really also a very interesting path to go. And we have worked on this quite extensively and come up with some, overall approach and tool, the RecMiner tool. This is, you can upload documents, legal documents here. So, you see on the left hand tab here, so this would be the document side. You can upload your documents here, then you can do some statistics on the documents, and then you can extract the compliance constraints in terms of sentences, but then also in terms of what we call mixed graphs. You see here, for example, a certain paragraph on the article, and we see on the left-hand side, this would be the constraints for this paragraph, on the right-hand side for the article, and we can see that therefore also, for example, some relations between these regulations. And we can cluster, for example, all these constraints and sentences according to certain topics. So, for example, for the GDPR, you could say, okay, which of these constraints and sentences refer to personal data or the controller and so on. And this might lead to a huge reduction of what someone has to read. And in another work, which will be presented also at the ER conference, actually, we have shown how we could then use this to directly compare, for example, or to directly check the compliance between process models and the texts. Yeah, and I think this is going really one step beyond what is possible right now. And the RegMiner tool, if you want to check, we have presented a demo at the BPM conference, and it's online. And here you can, check it out how this works. The other challenge was the distributed process thing, and here we see a supply chain example, which is also matching our good match for this manufacturing domain. And the distributed process means that we have several partners. So, for example, the supplier, special carrier, middleman, and manufacturer, and they interact with each other. And what this means is, so all of them have, let's say, a private process that they execute at their site. And parts of these processes are really private, so private tasks like prepare transport here. But then also they can have tasks that are public and visible to the others. And the interaction is established via message exchanges. And the overall network here is called process choreography. And if we have now constraints here, so first of all, we have to distinguish between different levels of constraints. So for example, we can have constraints that refer to the entire distributed process, and we call this global compliance rules. Yeah. We can have also local compliance rules, which refer to the, let's say, one process of one partner, can then therefore be checked locally. And then we have something what we call assertions. This is to make some, for example, assurance that something will happen. So for example, proving quality or adhering to contracts and so on. And what is one interesting, it's just an example problem here. This is, let's say, really still a big field to work on this. But one interesting problem here is that if we have a global compliance rule like here, then parts of this global compliance rule might refer to one partner, and another part might refer to another partner. And now the question is how we're going to check this, because neither the special carrier can see the tasks, the private tasks of the middleman, nor the middleman can see the tasks of the special carrier. Yeah, so the question is, how can we do that without harming the confidentiality or privacy needs by the partners? And here, lately we came up with some idea where we showed a decomposition algorithm that decomposes such global compliance rules into assertions. And these assertions in turn can be checked locally by the partners. Yeah, and we have presented this at the EDOC conference. And I think it's one first step to really dig into the area, how to support compliance in distributed processes in a comprehensive way. Yeah, this would be the assertions here. And you can see that, both of them can be checked by the partners in a separated way. And we have then also theoretically shown that a combination again leads to the original global compliance rule. So compliance in manufacturing, I would say the challenge of heterogeneous data sources is prevalent here. Of course, we have log data, sensor machining data, textual data, and image data. The challenge of distributed processes is also prevalent here. So we have complex production and logistics networks. And of course, we have several questions to answer, how to build up and run such collaborations at all. And then if there are changes, so this is the interface to the next topic of these runtime adaptations and changes, how can we define, negotiate, and implement changes? The negotiations part here is, for example, also really interesting because we have to keep in mind that these setting up such collaborations is really expensive and there are contracts behind, and a partner cannot just change something if other partners are affected. And it can also not change something and then just say, tell the partner, okay, take it and change your process accordingly, but has to ask beforehand. And then there has been some negotiation possibly. And what we have to keep in mind is that these changes might spread over the entire collaboration. So we have transitive effects here, and this can become also quite complex. We have also high demands for compliance monitoring during runtime. This can mean all different kinds of things. That can also mean, for example, that we stay in a certain time frame, or the sensors stay in a certain range, or things like that. And for us as academics, I would say good news is that there's a plethora of questions still open. We have already come a long way, but let's say these killer applications still pose some nice demands and challenges here. Right, then the last research area that I want to discuss in this presentation is runtime adaptation and repair. So this is also a really important challenge because manufacturing processes are not static. They can be subject to all different kinds of adaptations. This can be more exceptional things like, okay, there's some power outage or stuff like that, but also planned evolutions of the process where we can see, for example, realize optimizations. And this also holds true for other domains as well. For example, the medical domain, the logistics domain, and so on. And what we see is, what is important is that we have to be able to react to errors. So if there's something happening that we didn't expect, what can we do? And let's say as a basic thing, what we could do is to stop and start instances, of course. But then also what can help is to change the thread of control. For example, moving back in the execution or skipping some steps, inserting temporary tasks, and handle problems. And this is already possible and also has been applied to these use cases. And of course, you can think of that this is not just doing something at this graphical level, but we have to keep in mind that these processes are running programs that really drive systems, support human workers, drive machines, and so on. And changes here mean that we really change running programs. And so correctness, soundness, has to be the thing to keep at all means in order to avoid problems or unwanted effects later on. So if we think about having like an orchestration platform or a process platform for doing all these things in the manufacturing domain, and then with that ultimately result in all the digital transformation promises that we made in the beginning, the architecture could look like this. So of course the central part is the process execution, the engine, but also we have of course a strong design part. And here, this is interesting because we not only have the process models, but we have also these other data sources that we need and that also have to be designed, of course. So we have these engineering drawings. We have also, for example, resources that have to be defined. And then we come up with the processes. The processes then also need often some execution design, as said in the beginning. Then they can be executed. During execution, it's vital to be able to really connect the physical world here, to not only have like a symbol of some sensor, but then really have to connect to the sensor, to the robot, and so on. And then with that, we can collect the data in a contextualized and integrated way. The data can then be also prepared, aggregated, filtered, and so on. And then, there's all kind of different analysis possible. So we have a set of techniques, but also, of course, you can then develop and implement your own, let's say, analysis apps, how we call it here. And this is the framework also that we present to our industry partners, and which has been also tested now in real-world settings. So what can we learn from all this? I think what makes business processes so incredibly powerful is that they have this integration aspect. So they bring together the process logic, let's say the program logic, the systems, the machines, the human tasks, and everything that you have, and integrate them in a process-oriented way. This enables, in turn, the contextualized and process-oriented collection of data, manufacturing data, but also healthcare data, and so on. Particularly, we can now connect the process data also to other very valuable and interesting data sources, for example, sensor data. And this, in turn, enables then to think about more comprehensive data analysis, combined process mining and machine learning techniques, and then also enable a deeper understanding what is really going on. Also, what we touched a little bit upon during the compliance part is we can also integrate multiple process partners, so via these choreographies or distributed processes, and form virtual factories, for example, where not only one factory produces everything, but different parts, everything is put together, also connecting the logistics partners, and so on. There's some references that flew into these presentations, and there is many more. As I said before, this is just like some overview, and there's still things going on, and I think this will be go on for quite some time because we have so many challenging questions still. And I want to thank also, of course, Jürgen. He will also do the demo and the practical hands-on exercise then during the actual tutorial together with me, and then also Dr. Florian Pauker who is also our industry partner here and provided this very nice EFA use case. And if you want, follow us on Twitter, please. I want to give a glimpse in the real-world setting that we are going to have during our actual tutorial. And what we want to do is to demonstrate and together with you realize a complete scenario for a process-driven manufacturing application. And what you can see here on the right-hand side, this is a cobot. So we have them in our lab here in Vienna. And a cobot is a robot that can cooperate with the user. And then on the left-hand side, you can see here there's a tray with different objects. And what we are going to do is to have the process where the cobot is kind of scanning over the tray with the objects and then recognizing the objects automatically and then putting them on, you can see this in the foreground here a bit, on a specific position in the other tray. So this sounds maybe not so difficult, but actually there's a lot flowing into this process. So okay, the model, but then we have also the connection to the cobot. So we connect the cobot to the process. We let it do this recognition, but then we have to also specify where to put, for example, the object and so on. So I hope this is going to be interesting, and it combines, let's say at least these two worlds of BPM and IoT. And I think we can have also some other chat and discussion, of course, on the other parts I presented today. So, of course, if you have still questions or comments, I would be very happy to discuss that with you. Thank you very much and looking forward to the tutorial.